Okay, so this is the second part of our structural analysis video using the SAP 2000. So this will be our problem today. So this is a plain truss with all members, double angles 4 by 3 by 3 over 8 with short legs back to back. So these are the sectional properties, and this will be our basis of the structure. So let's proceed to the software. So our software, we have to create a new model, and then we have to check the units, and then proceed with clicking the two-dimensional trusses. Number of division is actually 4. The division length is 15. That's coming from our given 4 at 15, and then our height is 20, and the division length is actually 15. Correct plus 15. Click OK, then we will be directed to the command window. And I'm going to exit this three-dimensional view because I'm not gonna need that. I don't really need it. So, and then after that, I'm gonna edit the structure. Just have to delete this. Just have to add new number here, then here, then have to remove this numbers here because they are not the correct orientation. Then add new numbers and the correct ones. Then come over here, I'm gonna add here. Sorry. Okay. Then I'm gonna delete this. Add here. Then connect. I think it's so good if we just leave it like that. So after that, we have to make sure that we have assigned our support correctly. So that's actually a pin support. Click apply. This one, you didn't actually have to apply that. This is a ruler support. Ruler support. Click apply. And after that, we have to first, since it is an ideal truss, so there should it should be a all the connections and relations are fixed connected, so there should be no moment, no. There's only an action, no. Each member should actually be action. It's actually action. And so what we're going to do here is to release, no. We have to perform on the release. Assign. Let's go to assign frame, release partially, etc. Then we click this moment release, and then we click apply, and there. So we have these indications, or these indicators that we have a moment release. Then click OK. And after that, what we have to do is to define the materials. So our material is actually a steel, so we have to add a new material, steel, then click user, and click OK. And we just have to correct our inputs for the functional properties of the material. So that's 491, that's 0.491, that's 417, 6000, that's 417 thousand. It's 4,176,000. So That's 0.3, 6.5 times 10 raised to negative 6. That's correct. Then click OK. Then click OK. And then we have to define the load patterns. The section properties, of course. I import new property, double angle, and redirect us to the section property file. And just have to select the sections, the row, and then our section, the section property is actually double angle. That's 4 by 3 by 3 over 8. So it looks back to back. So you just have to go directly at 4 to 4 by 3. 3 over 8. So this is it. To 4 by 3 by 3 over 8. And click OK. Of course, our material, that's steel. And click OK. And okay. So after that, what we have to do now is to define the load patterns and the load cases. So for the load patterns, we just have to superimpose. Just call this I'm just gonna call this applied. These are applied loads. The other, that's still one, and then add the load pattern and click OK. And define the load combinations. Add the load combo. Just add the dead and the applied load. Then click this combination with our name. So I'm just gonna use it by default. And click OK. And then click OK. Then what else that we have to do is, of course, to assign the material properties that we have defined. So it's a frame section, and then you click this define section, apply define sections and the properties. Then so we already have assigned them. You click OK, and the last thing that we have to do before the running the analysis is to assign our loads. So those are applied loads. So those are actually joint loads. Let me begin with this node from our reference structure at node C. It's actually here, and it's an applied load, and that's along the global x-axis, but is going negative. So that's negative 2 pips. Now apply. Just have to wait, it's taking some time. That's there. And then we click at node E. It's along with the global z-axis, going downward, that's negative. So input is 0, is negative 1.2 pips from our reference. From the problem itself. And yeah, so the direction is going downward. Next is 1.5 pips at node F. Apply. Just gonna click apply. Then yes, we have applied all our loads. So nothing's left to do. That is to run an analysis. So I'm gonna click this OK, and then run an analysis. Then the dead and applied. Run now. Just select the dead and leave. And I'm gonna save this file directory. This is B. It's actually retain press. Let's see, existing. And so it's already running an analysis. I'm just taking some time, but it is far more direct than doing it manually by hand. And really mind-blowing. So this is our deform shape, and so what we are to apply to actually identify. So we can check the reactions here and not the supports. Then actually check the reactions, no? And yeah, the dead load, you see applied load. Let's see. So yeah, then it's for a load combination. You can see it. So that's how we look at it, how we look at the supports. So at the applied load, so those are supports, the reactions of the supports. The combination is a lot bigger supports, combine loads from the applied and dead load. So next is we're going to view our the shear, I mean the actual force. If we're being asked for the shear, so we can define them. So okay, let me provide the shear. Let us visualize the shear for the dead load alone. So apply. Only show the values and not the thing one. So this is our the diagram. How about the shear? I'm going to apply. And that's the shear. 22.033 so none. It's actually the relation to y0 in the axis that is corresponding. And again, for an easy identification of the forces of the members, so we can actually just close this, open, view the table. Display the analysis table. So the element output, just gonna check the element output, and then the joint output, of course, and then click OK. It will show me the table containing all the the supports and etc. The element forces or the frames. So these are the shears. The actual force and the actual forces. So of course there are just the moment values. Yes, so these are the supports, and that's it. That's how we use the SAP software in analyzing 2-dimensional frame truss. So I hope you enjoyed it. Watch out for the last part of the video, an analysis using a rigid structure, a rigid frame. So long.